Thank you very much. Sorry. Thank you very much. We're going to see a presentation now on CFCs and CFCs, chlorofluorocarbons, and the work to understand what impact they were having on the ozone layer and to control those things with the Montreal Protocol has actually been the most important climate action that we have yet taken. And so because of the work from NASA and colleagues around the world on keeping track of CFCs and understanding what was going on, we're in a better place than we would have been otherwise. And this is one of our scientists working at the NASA Goddard Space Flight Center who's going to take this forward, and we'll be happy to answer questions about this once she's done. Thank you very much.
Goddard Space Flight Center. Today I'm going to talk to you about how NASA research has helped the Montreal Protocol to regulate chlorofluorocarbons, aka CFCs, and how this has helped the stratosphere ozone layer to recover and Earth becoming a better planet for human health and vegetation. Next slide. Ozone is Earth's natural sunscreen. Ozone in the upper atmosphere helps to shield harmful UV radiation in reaching the surface to cause skin cancer and damage vegetation. CFCs used to be chemical compounds used widely in a variety of applications, such as aerosol sprays, refrigerants in air conditioning systems, fire extinguishing agents, or insulation foams. Many years ago, scientists found that CFCs that have very long lifetimes could find their way into the stratosphere. In the stratosphere, they can decompose under sunlight and release chlorine atoms and destroy stratosphere ozone. Next slide. Because CFCs are harmful to the ozone layers, all countries around the world came together in 1987 to sign the Montreal Protocol on substances that destroy the ozone layer. NASA's research enabled a series of international reports on the ozone layer, which played an important role in the signing of the Montreal Protocol. The Montreal Protocol and its amendments require 100% phase-out of CFC's production and use in the developed countries by 1996 and in the developing countries by 2010. As a result of successful regulation by the Montreal Protocol, atmospheric abundances of CFCs have been decreasing as expected since the mid-1990s, and the stratosphere ozone is on its road to recovery. Next slide. NASA has been continuously monitoring the status of the ozone hole using satellites as well as ground-based measurements. Showing this slide is the evolution of springtime total ozone within the Antarctic ozone hole from 1979 to 2016. As we can see, the decrease in minimum daily ozone level over the Antarctic leveled off around the 2000s and has slowly increasing in recent years. NASA scientists Dr. Susan Strong and Dr. Ann Douglas published one of the first studies in 2018 to directly show that ozone depletion is decreasing as a direct result of a decrease in the presence of chlorine from CFCs. This proves that the Montreal Protocol is working, and we might have turned a corner on ozone depletion. Next slide. It is great that our satellite observations are finally showing that the scientists were right about CFCs causing the ozone hole, and there was a great collective effort by the scientific community and the policymakers in signing the remarkable international agreement to regulate CFCs and other similar ozone-depleting compounds. The interesting question that people sometimes wonder about is, what kind of world was avoided by phasing out ozone-depleting substances? This video demonstrates what ozone looks like in our current projected world with the Montreal Protocol regulation versus a hypothetical world avoided scenario. In the world avoided scenario, CFC emissions would increase from 1974 upward at the hypothetical 3% annual increase rate. As CFC emissions increase, the atmosphere abundance of ozone-destroying chlorine would also increase rapidly. By the end of the simulation, in year 2016, the chlorine level in the hypothetical world avoided scenario is about 300 times higher than that in the world expected scenario. As a result of this very high level of chlorine, about 2/3 of the atmosphere ozone would have been destroyed, not just over the polar regions, but around the entire world. The resulting UV radiation will be up more than 500%, and this can cause sunburn in mid-latitude cities in just 5 minutes, making it literally impossible for people to spend time outdoor without any protection. Next slide. In addition to benefits on human health and climate, the Montreal Protocol also have brought benefits to the Earth's trees and vegetation. A recent study has connected the ozone layer to plants and the terrestrial carbon cycle and demonstrated that how Montreal Protocol has protected the carbon sink in climate. Same as the previous experiment, the team led by Dr. Paul Young at Lancaster University used a series of models to simulate two hypothetical scenarios: the world projected and the world avoided, with 3% annual increase in CFC emissions. In their model of the world avoided, the global thinning of the ozone layer would let more harmful UV radiation from the sun to reach the surface, and this would effectively sunburn the plants. Subsequently, this would make the Earth's trees and vegetation to be less efficient at photosynthesis and will limit their ability to absorb carbon out of the atmosphere, and therefore not be able to store carbon in their tissue or in the soil. As a result, atmospheric carbon dioxide levels are estimated to be 30% higher than they would likely to be under the Earth's current trajectory. Consequently, Earth would likely to be 0.9 degrees hotter in the world avoided scenario just due to the impact of plants. This warming is on top of the 1.7 degrees of direct warming due to increased CFC-11 emissions in the avoided scenario. Together, these two effects would make Earth a much hotter planet, about 2.5 degrees warmer than in the projected scenario. Next slide. While we are all excited that the Montreal Protocol is working and the ozone layer is healing, it is very important that all nations of the world continue to abide by the Montreal Protocol and its amendments that ban CFC production and usage. Continue the monitoring of the status of the ozone layer and the abundance of ozone-depleting substances in the atmosphere are critical in assuring this compliance. A recent unexpected breaching incident is a good example of such problems. In 2018, a paper published by Dr. Steve Monska from NOAA reported that there was an unexpected slowdown in atmospheric CFC-11 decline rate, indicating an increase in its global emissions. However, due to the limited spatial coverage of the NOAA observational stations, they were unable to pinpoint any regions that were responsible for this emissions increase. After the Monska paper was published, the A-Gauge network community, funded by NASA along with other international agencies, found frequent occurrences of highly elevated CFC-11 in two East Asian stations, Gosan in Korea and Hataluma in Japan. Because of the unique locations, using these surface measurements, the A-Gauge scientists were able to identify one major source region of these unexpected CFC-11 emissions. They estimated that emission from eastern China had increased 7 gigagrams per year in 2014-2017 compared to previous years. This increase accounts for about half of the global emissions increase. After the problem was reported, there seems to be extensive effort by the Chinese government in tracking down the illegal production. A few years after increased CFC-11 emissions, we have noticed that recently the highly elevated CFC-11 concentration spikes were going away in these two Eastern Asian stations. The A-Gauge team estimate that Eastern Asian CFC 11 emissions in 2019 have decreased by a factor of 3 to 5 gigagram per year in 2019, and is now returning back to the pre-2013 level. Next slide. A question we have been frequently asked is, what if we didn't discover the unexpected emissions increase, and we didn't stop the illegal production of CFC-11? How would the excessive emissions have impacted the ozone recovery? Showing this slide are model sensitivity simulations with 2 runs demonstrating what would have happened to the Antarctic ozone hole if these emissions continue well into the 21st century. The globe here shows the level of ozone observed over Antarctic in 2019 with a very visible ozone hole in the Antarctic. As demonstrated in this blue line here, which indicates full compliance with the Montreal Protocol, the Antarctic ozone is projected to gradually return to the 1980s level by 2060. However, under a hypothetical scenario, when the illegal CFC-11 emissions continue unabated, the red line shows what happens in the avoided high CFC-11 emission scenario. In this scenario, Antarctic ozone hole will not fully recover by the end of 21st century. Total ozone over Antarctic, average over the last 20 years of this century, shows a very visible hole with a size comparable to the full Antarctic continent. Next slide. The incident with the unexpected CFC-11 emissions increase proves the importance of continued monitoring of levels of ozone-depleting substances in the atmosphere. Currently, this is primarily done through the surface monitoring networks. However, the surface networks are limited in terms of spatial coverage. As a result, half of the identified increases in the global CFC emissions surge remain unaccounted for in terms of the potential responsible regions. Some new research by a team in University of Michigan reported preliminary retrievals of atmosphere abundances of CFC-11 from the lower atmosphere using the atmosphere infrared sounder instrument on board Terra Aqua satellites. These retrievals could potentially greatly enhance our monitoring capacity for CFC-11 and its link to surface emissions around the globe. Together with the surface monitoring networks, this new product may help shed new lights on Montreal Protocol compliance in the future. This is my story for today, and thank you very much for tuning in.
If anybody has any questions related to this or related work, we'd be more than happy to try and address them right now. Or not, that's fine.